Just 30 years ago, this is what computers looked like. Big boxes full of tubes with not much more computing power than a modern-day handheld calculator. Back then, only a few knew how to operate them. But change hit with the force of a lightning bolt. The industry thundered toward miniaturization and speed. Cost went down and use went up. Today, the world runs on computer power, from Wall Street to Hollywood, medicine to manufacturing. This explosion has created a huge demand for computer scientists, people capable of building, programming, and working with others to squeeze the most out of these complex machines. The Department of Computer Science at Colorado State University has been filling that demand since the days of the big boxes. Throughout the evolution of the computer, the department has focused on the fundamentals. Faculty help students gain an understanding of sophisticated computing concepts and principles, the building blocks of change. It's the type of education designed to last a lifetime.
So that when they leave us as seniors, they have both of these components. They've got current skills that are employable, and they have learning tools that will keep them employable and make it possible for them to grow very rapidly in their professional careers.
For example, when I teach the computer programming languages course, I focus on the skills needed for a student to learn a new language rather than teach them 5 languages. Because when you get out into the working world, no matter which languages I pick to teach, your employer will decide you need to use a different language.
So I think it's important that people get concepts that will give them a basis upon which to adjust and contribute as experts to changing technology. And in our field, it changes all the time.
Having a firm grasp of the fundamentals allows an aspiring computer scientist to go anywhere in an industry that's going everywhere. And they get there by the strength of their creativity. The power in this profession lies not in the hardware, but rather in the spark of a student's imagination. That's why the computer industry looks to Colorado State for fresh ideas and new employees.
I think one of the advantages of the program at CSU is that students get a very good exposure to a broad range of equipment, to a broad range of environments, to a broad range of system environments for development of solutions as well as for computer hardware.
Colorado State and the computer industry have forged a partnership for the future. The laboratories of Colorado State attest to this partnership and reflect the depth of commitment by industry. Many major computer manufacturers have donated the latest equipment. They've created a real-world environment in which students explore tomorrow's questions using the best technology of today.
We have the benefit of graduate and undergraduate people maybe stressing our equipment in ways that we wouldn't think of or that our normal customer wouldn't think of.
Industry's input and equipment shape the modern curriculum which guides these students. Overall education is given a boost by active research programs. Faculty investigations focus on software engineering, parallel processing, and artificial intelligence.
We use backgammon just to visualize what is actually being learned by this neural network. And in fact, the same learning algorithm can be and has been applied to learning in manufacturing processes, learning the control of a robot arm. It's a wide gambit of applications where these algorithms can be applied. And here at CSU, we are trying to advance the capabilities of these learning algorithms, making them more general and more robust.
Inquiry into the theoretical charges the environment, keeping the professors sharp and your education current.
Autotrol is a company that produces computer design and manufacturing software. So we're hot at the graphics.
Students also learn outside the classroom and research laboratories.
This project down there, what of that can you...
This is a senior software design team meeting with their industrial sponsor for the first time. Terry Wirtz is a software engineering manager. Carol Getz is a senior engineer in the software architecture group. Carol and Terry work for Autotrol, a company that produces manufacturing software. Auditrol has asked this group of Colorado State students to rewrite an existing defect and enhancement tracking system.
It's one of those areas you're going to want to get your feet wet. And if you can walk out of college with this on your resume using object-oriented methodology, you can probably write your ticket into some company. So it's worth...
The group meets regularly to discuss matters among themselves. Early on, they established a division of labor. Carrie Knutson is the group leader. She keeps things organized. David Manzanares brings strong management skills to the group. He's been interning at IBM for the past year. Zui Hung is a graduate student from China. He makes sure everyone's assignments are in on time. Jeff Miller is the group's researcher. Tong Nguyen just switched majors and provides strong technical support. During the semester, they went to Auditrol to get an idea of how the old system works.
Major dissatisfaction among the people that don't like it, users, are the user interface, the tools that it was on. And that's why we're really interested in getting into new tools.
Each time they meet, they move one step closer to their goal. Each time they learn more about the system, more about the corporation, more about the technology.
Data tree that we're using it in right now fails all the time. So by using Oracle, we're going to come up with a relational database. It'll work much better. We're not going to have to do as much maintenance on it.
In this particular project, they're going to be working on some of the leading edge technologies concerning graphical user interfaces, relational databases. They're going to be walking through formal project planning and documenting. They will have gone through formal reviews. Very few students walk out of computer science departments knowing how those are even supposed to be held, much less being able to write it down on their resume.
Each time they meet, they also learn something that goes well beyond the technology. They learn how to work with each other.
All software projects today, or nearly all, are done within groups. They struggle with the issue of, can we all meet at the very same time? Can we get the task assigned? Can we get the task executed against schedule? The same as we see in industry. They really are a project development team, despite the fact they're still students.
Basically, the main thing I think is just working as a group, communicating as a group, where each person has, separate tasks, and they're all one task in a sense. So everyone has to pull their own weight. When there's problems, communication about those problems, and so on and so forth.
They're going to come out of this experience much more secure in their technical knowledge. They're going to come out much more skilled in their process knowledge. They'll be able to parlay this experience into their future and ride on the level of experience they have right now.
The demand for the skills of a technically competent computer scientist will continue to increase as the world becomes more automated and more complex. Colorado State will continue to fill that need with well-rounded, technically sound professionals. Computer scientists well-grounded in the principles, familiar with the experimental, fully prepared to take on the questions of an exciting and challenging future. For more information, contact James Peterson at the Computer Science Department, Colorado State University.